All right, everybody, we are live from Pipeline Workspaces here in Fort Lauderdale. This is Philippe Hodar. He's been a friend of mine for quite a while now. I've known him for I'd say about 10 years or so. We're going to be doing a really cool talk today about hurricanes and how our climate change has kind of affected the hurricane season of 2017. We're going to open it up to questions. You can ask whatever you want to ask. How to bake chocolate chip cookies is fine. I won't know the answer, but it's perfectly fine. So just give us about a minute. We're going to be sitting here kind of awkwardly because I'm going to share this on the CBS12 page, and we have the folks here sharing this on the Pipeline pages right now as well. And then Philippe is going to moderate this, and we're going to get your questions. It's going to be all cool, but just give us a couple of seconds to get this going. All right? And we're going to start this probably in about a minute or so. So get your questions ready. All right, folks, another 30 seconds and we will get going. Just waiting for some people to come online, and I'm just sharing this in a couple different places. So, all right, that should be good. All right, so I think we can probably begin. Do you guys have it shared on the Pipeline Spaces? Okay, pages. All right, so I'm going to kind of hand the microphone over to you.
Great. Well, thanks for being here, Jeff. A lot of us are followers of yours on CBS here in South Florida, focusing on meteorology and all things related to climate. We thought to invite you here today and really appreciate you making the time. For us, we have a lot of our members and people that live here in the area who have a lot of questions concerning the recent hurricane season. It seems like there's a growing intensity with the hurricanes and more frequency with the hurricanes. There are a lot of questions around has climate change played a role in contributing to this? And if so, what is that? What can we look to in the future? And so we just wanted to have a conversation around that. And you're an eminent scientist, and I think have a lot of insight that can be useful for helping us think about that. So again, thanks for being here.
It's been an astonishing hurricane season. It really has. Now, 2005 was also an astonishing hurricane season. So there's definitely a cycle going on here. Some years are weaker. Some of that has to do with La Nina versus El Nino. Other seasons are more intense. But what we saw this year was a peak in intensity due to a natural cycle, and then some part of it being climate change, being forcing that's caused by human beings, by warming in the atmosphere, warming in the oceans. So it really is kind of hand in hand. And what we can expect in the future is, during weak seasons, you may not experience too much of an impact because there's something kind of fighting against hurricane season from being very strong, if you will, during those years. It's a natural cycle. But when the cycle peaks, the impacts of climate change on that peak cycle will also peak. And so you end up with these adrenaline type of hurricane seasons like we had this year. I think anybody who was watching this hurricane season, even people who don't believe that climate change is real, have to be like scratching their heads saying, this just doesn't seem natural. We can talk about all the details on that as we go along here.
Yeah, I think that may be an interesting part to start off on. Can you set the context for us about how this season is represented compared to other hurricane seasons going back, 30 years, 50 years, 100 years?
So it's been really active, and the way that we measure that is not necessarily in terms of the number of storms, because you can have 20 storms, but they can all be tropical depressions. Who cares, right? When you really start to care is when you have a really strong hurricane or many strong hurricanes like we've had. So we use something called ACE. ACE is accumulated cyclone energy. And so basically there's a mathematical representation of when you add all the storms together and you also add in how intense those storms were and how long they lasted, you come up with a number of energy units. So accumulated cyclone energy is how much energy was used by a certain storm in the season, and then you add all those storms together and you have an ACE. So in terms of ACE, since 1950, we are right now, and I have to check my numbers, we're either the second most active hurricane season or the third most active hurricane season in terms of ACE. 2005 was the highest, and that's because 2005 had over 30 named storms. It was a crazy season, or maybe I'm not right. It could be less than that, but it exceeded the alphabet, and we had to start with alpha and beta, which is extraordinarily rare. So 2005 was our most active hurricane season, and this one really would probably be number 2. Yeah.
Okay, and I guess based on this, what is the science saying about what's contributing to that level of intensity?
Well, first of all, what was taking place this year was we had very calm winds in the upper atmosphere. So you hear us use the term wind shear a lot. So we didn't have much wind shear out there. Also, water temperatures were way above normal. In some cases, 1 degree above normal. In some cases, as much as 3-4 degrees above normal, depending upon what part of the ocean you were looking at. The western Gulf of Mexico, when Harvey hit Texas, water temperatures in certain pockets were 2 to 3+ degrees above normal.
Is that a temporary elevation in the water temperature, or is that something that's been happening over time?
It's both. So, you know, I spoke to a scientist, Kevin Trembeth. He's at NCAR in Utah. He is a preeminent climate scientist. He helped write one of the first IPCC reports. I did an interview with him during the summer, and then I actually spoke to him over email a couple days ago. And he talked about ocean heat content building up underneath the surface. So we always look at the surface of the oceans, but almost what's more important is what's happening below the surface, 100 feet, 200 feet down. And what happens is a lot of the heating of the ocean that's being caused by climate change is not just going into the surface, it's being heated down below. So now you have a storm which is kind of moving along, and as it moves along, it's using up the surface water to kind of feed itself. That's what hurricanes do. To feed themselves, they use up surface water. Now, if the storm's moving slow enough, it'll use up all the energy on the surface. If underneath the surface it's cold, the storm will start to weaken because it doesn't have that energy anymore. But if underneath the surface it's really warm, there's a high ocean heat content, which there is now because partially due to climate change and partially due to cycles like El Nino and La Nina, now you have a source that can constantly be replenished. All this water upwells and it's warm water. And so these systems can sustain themselves longer. We saw that with Irma. Irma was able to sustain its winds of 185 miles an hour for 37 hours straight. It's nothing we had ever seen as meteorologists on record. At least we can only go back so far and look at these things. But we'd never seen it in the Atlantic Basin. We'd never seen it in the Pacific Basin. As a meteorologist, I've been doing this a long time, in Florida for a very long time too. I would expect potentially to see something like that in the Pacific Ocean. Would never expect to see it in the Atlantic Ocean. It happened this year because of both a natural and also what seems to be climate change contributing to this.
Wow. So we're interested in how this affects South Florida, but it seems even outside of our region that there's a greater sort of likelihood of hurricanes reaching areas that we'd never thought of. Ireland, up in New York recently. There, what's happening with that?
Yeah, so there has been a hurricane in Ireland back in like the, it could be the 1950s or 60s, I think it was. When this particular storm, was it Ophelia? It was Ophelia, I believe, that reached Ireland this year. When it reached it, it was no longer a tropical system, but it had winds as strong as a tropical system. That's what typically happens. These old tropical systems in the northern Atlantic tend to become extratropical or post-tropical before they hit Europe, but they do occur often enough. What happened this year, though, is it formed very far northeast in the Atlantic, something that we rarely ever see, and it maintained some of its tropical characteristics almost to the point where it got to Ireland. It's very rare that that would happen, but if it was going to happen, it would happen during a very active hurricane season like this. Hurricane Sandy, the anniversary was a couple days ago. That, of course, hit New York 5 years ago. Again, for hurricanes to hit the Northeast, not all that uncommon. What became very uncommon, and some of the climate scientists are kind of raising the red flag, ringing the bells, saying that Hurricane Sandy was not just a natural occurrence, but there was also some climate change in that. It gets a little complicated here, but basically what Hurricane Sandy did was coming north, and then all of a sudden it took a hook into the coast. The reason it did that is that there were these somewhat abnormal blocking patterns in the atmosphere to the north and to the west of Hurricane Sandy, especially to the north. What we expect from climate change is that the jet stream will begin to weaken. Now, it sounds counterintuitive, but it's actually really easy to understand. The reason why the jet stream weakens is because it's not as cold at the poles. So it's not as cold in northern Canada. It's not as cold near the North Pole. And because of that, the contrast between cold and warm weakens. Because the contrast weakens, the jet stream weakens. Because the jet stream weakens, it starts to flow more slowly. It moves more slowly, and that creates a blocking pattern in the atmosphere where it's kind of like a traffic jam. So Sandy got caught up in a traffic jam, and the system ended up hooking right into New York. Now, that happens naturally sometimes, but climate scientists are saying that some of what happened with Sandy was in fact not natural. It was caused by this new thing that we're seeing in the atmosphere, which is slower atmospheric rivers, more blocking, and thus stranger movement of storms. And obviously, if you have warmer water, you can see us right now, but just give us a second. We're good?
Yep. Great.
Okay, we're good. And by the way, do you see any questions? And the reason why I asked that is I want to make sure people can hear us.
Yeah. A couple of questions.
Okay.
Great. Maybe this is a good time to see if there are any questions either from folks here or from people online.
And you guys can't see it, but there's some audience members behind us here. If we can get a standing ovation, that'd be... No, I'm just kidding.
Does anybody here have any questions?
Does anybody have a question? No? Okay.
I have one online from Patrick that says if we're looking to see that hurricane season is going to last longer with all these changes.
That's a good question. So you want to repeat the question?
Sure. So Patrick online is asking if we can expect hurricane season to last longer than it has in the past.
You know, that's actually a really good question. I don't know what kind of research has been done into this. Oftentimes, you'll hear us scientists be very nerdy and say that we don't like to answer questions unless there's research to support those questions. I mean, it just seems like a legitimate question, though, and logical that if the waters stay warmer longer, that you might actually see hurricanes a little longer. Now, there's something else that goes into that, though. You can't get a hurricane when you have really warm waters, but there's a really, really strong wind shear in the atmosphere. One thing that we know in the future, that computer models are showing us, and climate scientists are coming up with, is something that may seem counterintuitive. There may actually be less tropical systems in the future because wind shear may actually go up. So let's say the average amount of hurricanes or average amount of tropical systems right now is between 10 and 11 per year. It may be between 9 and 10 30 years from now. But the other thing that we find in our computer models is that those storms are likely to be stronger. The strongest of them will be stronger. So you get perhaps fewer storms, but they are stronger storms. So the answer to the question is can we expect hurricane season to last longer? I can't tell you a definitive answer for that because I do know water temperatures will be warmer for longer. But what I don't know is how that impacts the wind shear in the upper atmosphere.
Okay, great. I think you had a question?
Yes. So this might be a little silly, but for those of us who hunkered down for Irma, there was a lot going on social media about a couple of events where people wanted to gather together and throw ice into the ocean. And
yeah.
The theory behind it, I mean, it kind of sounds ridiculous. I laughed when I saw it, but the 8th or 9th time it came up on my newsfeed, I said, well, if it is water temperatures that's rising,
yeah.
we had enough people. So I'm
yeah.
just curious to see if there's any validity to something like that.
So what's your name, by the way?
Jen.
Jen. All right. Jen here at Pipeline here in Fort Lauderdale had a question which was, can we throw ice essentially into the water? But really what you mean is there any way that us as human beings can artificially intercept or stop these storms?
Yes.
Something that we can do. I've heard people say, let's use oil, let's use olive oil. As an Italian, no, I like olive oil. Please use some other type of oil, corn oil, something else. But with that said, these all make sense. It's a certain type of engineering to kind of save ourselves from this. Well, I would say that these ideas are somewhat viable, although it would take, I don't know, it would take all countries banding together to take every bit of ice they can possibly find and throw it out there in front of a storm. Now, is it possible? Maybe, but it would be a Herculean task. But I think the bigger problem is we don't know what the impact of that will be, right? You throw a bunch of ice in front of a storm. Storms are, I won't personify them other than to say that they're smart. That is personifying them. But storms actually do seek out warmer water. So they may just kind of try to go around it in a way, especially if they're moving slowly. I don't know if you've ever noticed this. Did you notice when Irma was creeping along the Cuba coast, it never went inland. It kind of just creeped along the shore. So it was actually avoiding going over land because it was looking for where the next bit of energy was. So it was staying over water. So if we throw a bunch of ice, again, it's not a possibility right now, and I don't even know if it'll be a possibility 100 years from now, but it's a good question on geoengineering. If we do that, the storm may actually try to find warmer water. So a storm that may be going towards Miami may all of a sudden start going towards Fort Lauderdale, or may start going towards West Palm. So even if we could do it, what are the ethics involved with sending a storm to a different area? Sure, it may not come towards Miami, but it may go towards Nassau in the Bahamas or Freeport. So it's probably not a good idea to play with Mother Nature. But I get what you're saying, and yes, there's some promise in geoengineering, but I don't think we're there yet.
In fact, I think we heard other types of questions immediately prior to this session where somebody asked, even dropping a bomb, and we heard this coming up also during that time, nuking the hurricane, so to speak. So there's some sort of extreme uses of technology that are being bandied about. Do you ever hear that coming up, and how do people think about that?
And I don't know what the impact is of nuking a storm. I don't know where it's going to send the storm. I don't know how it's going to impact the storm. And I don't know how it's going to affect us with all the nuclear fallout from, I just don't know that we're there yet. And I don't know that we're going to be there in my lifetime at least. And we can probably start with some small changes, but we just don't know what the impact of our intelligence will yield, if you will. Yeah.
Any other questions that we're seeing? I've got.
It's pretty common to get questions like these geoengineering. I see a lot of these. And I think there are some people who really believe that the government knows how to do this stuff and is doing it already. And I don't have any knowledge of that. And these are Herculean tasks that are being asked of us.
I guess one of the topics that comes up often here in South Florida is rising sea levels. And I happen to live on Brickell here in Miami, and there was the storm surge which came in. The water was probably 2 or 3 feet above streets for probably about half a day before it quickly receded. How does the prospect of rising sea levels affect the impact that hurricanes will have on this area?
Well, undoubtedly, as sea levels rise, the storm surge will rise along with it. The problem we have here in South Florida, and if you're from South Florida and you're watching this, you kind of know this, especially if you're from Miami-Dade, especially if you're from Fort Lauderdale. Maybe not as much if you're from Palm Beach North. But the water's coming in from underneath in many cases. Now, in storm surge cases, it's actually just flowing in, from the bay. And for that purpose, we could actually build some walls to kind of help keep the water out from storm surge. It'll still get around it. You'd have to build a huge wall, gargantuan wall. The problem, though, on a daily basis here, especially on new moons and full moons, is that the water's seeping up from the ground. Yeah. Of course, there's that iconic picture, I don't know if you guys have seen it in the audience, of the octopus in the parking garage in Miami Beach. That octopus came up through the aquifer or came up from the sewers or whatever it was. I know the guy who shot that video. He shot it in the Mirador on West Avenue and 10th in the parking garage. And it just goes to show you that the ocean's coming in from underneath. So how do you, now if you're Venice, you just build canals and you just raise, perhaps you raise some of the building. It's difficult in a place like Miami Beach where the water's coming up from underneath and not just in from the sides. And that's something I'm not necessarily an expert on. But I do own a condo in Miami Beach on an island. And so I'm concerned myself as to what that's going to mean for the somewhat distant, and also short-term future as well.
Yeah, well, that's a common topic of conversation these days, is what can we look forward to over the next 10, 20, or 30 years here in South Florida with regards to that?
Well, luckily sea level's not rising extraordinarily rapidly. At this moment, at least, we still have the ability to make changes in the short term that'll help us. I mean, obviously, the mayor of Miami Beach right now is working on what is a $400 or $500 million project to install pumps, cause lots of traffic on Miami Beach as well. But with that said, it is all in an effort to try to figure out how to get rid of this water when it starts flowing in. The pumps, the raising of streets. Of course, there are some impacts of doing that. We saw that obviously on Purdy Lane, or Sunset Harbor. But with that said, sea levels are accelerating in terms of how fast they're going up every year. So right now we can deal with it, but in the future they're going to rise more quickly. And the one thing we don't know is if there's a tipping point. We don't know if all of a sudden, Greenland's been melting at a certain pace. We don't know if Greenland and Antarctica, as they start to lose the ice that kind of shields the ice sheets in, if that's going to start happening at a more rapid pace, if ice is going to start sliding in from land at a more rapid pace, and now all of a sudden your sea levels are rising much more rapidly. So I think we're okay the decade or two to come of kind of just coming up with solutions that allow us to live there. But what happens, 30, 40, 50 years in the future? The projections are, the realistic projections are about 1 foot by 2050 and 3 feet by 2100. That's the average. There are some, people, some climate scientists that say no, it's going to be closer to 6 feet by 2100. But a lot of that has to do with how much we curb our emissions. And that brings us into another topic, right? Is there much hope for the curbing of emissions and bringing the amount of CO2, stabilizing CO2? It's hard to bring it down unless you're sucking it out of the atmosphere, because CO2 lives in the atmosphere for hundreds, if not 1,000 years. And we can talk about that, too, if you want to talk about alternative energy and moving in that direction as well. Did you have another question before we get into that? Because that's a big topic in itself.
Anybody?
Have you seen any questions you want to ask from viewers on the other side of the phone, guys?
More comments than
A lot of
questions.
comments. Okay.
Yeah.
Any death threats yet? Well, I heard she smiled, but she didn't say no, so it's a little concerning.
Okay.
Yeah.
So
What's your name, by the way?
My name is Philip. So I'm trying to
Philip. Okay, sure.
Unfortunately, I work finishing projects, but I'm an engineer, so I have a little bit of understanding on some stuff. What I'm curious is, to me, it's almost like medicine. So I almost view the planet like our human body. That prevention is probably the best
Right.
action than actually dealing with the problems. Because like when you're mentioning geoengineering, in theory, it makes perfect sense. However, I believe they calculated the Earth to be like something like 140 quadrillion, like some ridiculous number of resources needed to even do anything. So
Yeah.
it's very futile and actually comical for us to think that we can.
So wait, before you go any further, let me just say, Philip is talking about how difficult it would be to geoengineer, because it would take Herculean amounts of resources. And also, what were you saying before that? Prevention is better. Like in medicine, prevention is better than trying to take an aspirin after you have a headache. Try to avoid having the headache in first. Okay.
You were mentioning how the hurricanes will be affected. I mean, I picked up a little bit later on your talk, but how you were talking about the hurricane would actually react to our changes that we try to do. It's very similar to the human body. Like nature has taken millions of years to perfect the formula to be more efficient as possible. So it's almost like to me, almost as an engineer, it's comical to think that we can engineer.
Right. As an engineer, he's saying he thinks it's comical to think that we could actually, are they saying that they can't hear? Is that what they're saying behind the camera? Okay. He's saying that it's almost comical. He's an engineer. It's almost comical to think that we really could somehow make changes, and if we do, what kind of repercussions there would be.
We can, but it's going to be very trial and error, and obviously would take just a very distinct amount of time for us to actually figure out if it's better or worse. I think really what we need to focus, and this is my personal opinion, is again prevention. Is figuring out how can we use alternative technologies, which is probably what we're going to segue into, to prevent doing things that we already know but are effective. For example, another thing I thought was very interesting, and there's also a lot of politics involved too. Canada melting, the whole trade routes between Asia and North America will completely change, and everything could potentially shift from the Panama Canal to the top of Canada.
Right.
And Canada wants that to happen, but everybody...
That's interesting. Okay, so you said a lot, and I don't know how much of this actually we can hear on the other side of the camera.
I mean, I guess the question is, with regards to prevention, beyond curbing CO2 emissions, what are the different things that that are being discussed in public policy, and what can be implemented to try to slow down or reverse some of these changes?
Well, first of all, there's this carbon sucking technology that they're trying to employ. So that would be essentially a geoengineering thing. But first of all, it's not proven to scale. It's fairly expensive right now. They're starting to do it. They're hoping they can outfit industrial complexes and factories with this technology, but it's not nearly there yet. By the time that figured out, we will have emitted too much carbon dioxide, if we're on this business as usual kind of route. We need to take action before that. And the only action is stopping emitting a lot of carbon dioxide. There's no way around it. Methane, but carbon dioxide more importantly, because there's a lot more of that around. But here's the good news. And you as a person who's a businessman, as a person who's dealt with economics, the economics are finally there. It is now almost as cheap, if not as cheap, to buy an electric car. Batteries storage is being worked out. Pretty soon it'll be great. I drive a Prius. Pretty soon I'll have an electric car, and you drive a Prius too. There you go. Also, one of the biggest things is that if you're a developing country right now, and you know this having worked in the developing world to some degree, it is now cheaper to build power plants in solar and especially in solar than it is to use fossil fuels. So it's now the economics are there. It's cheaper. People always buy cheaper, if they can. If they can save $200 a month in their monthly gas bill to drive to and from work with their car, they're going to get an electric car. Volvo just said they're going to stop building gas cars soon. Ford and GM has said, I think, the same thing. So we're seeing a revolution take place, and it's happening not because people want to be nice to the environment. It's happening because it's more economical. It's going to cost us less. Plus, we're going to see self-driving cars pretty soon. So a lot of people won't even have cars. So there's a big revolution that's going to be happening over the next couple of decades, not only personally because you're going to have an electric car or no car at all, but also because a lot of the new infrastructure in power is going to be solar just because it's cheaper.
Yeah. And what? Yep, we have a question now.
If you want to finish that topic, and then it's a little bit on. Actually, about the ecosystems and how you were saying that hurricanes are going to be stronger now. Not so much that there's going to be more or less, but that they're going to be stronger. We've noticed in this past that it did affect our ecosystem as far as fishing and all of that goes, as well as let's say for Florida, oranges and those types of industries. How can we prevent, let's say for ecosystems in the water, how can we prevent, that dying out and having...
You mean coral reefs?
Well, and among other things, yeah. I mean, and
fish
people
populations
that livelihoods are based on fishing and
yeah, it's a big topic. Coral reefs. Do you know that 90% of the Florida Keys coral reefs have vanished since the 1970s? So 90% of the living coral that used to be there in the 1970s, according to scientists who study it, is gone. It's hard to believe. Now, that's not all climate change. Some of that is warming water and bleaching. That's definitely a big part of it. Other parts of it is just tourism. It's just, sunscreen, is people in their boats. It's just lots of people. But we just saw a huge die-off of the Australian barrier reef there. And it has a huge economic impact because so many people go to Australia to dive the barrier reefs. Why would they go now? So much of the barrier reef has been bleached or is dead. And it takes dozens, in some cases hundreds, in some cases thousands of years to replenish those reefs back to normal again. So, the question was bigger than just coral reefs. It was fishing. But that now you're delving into overfishing to some degree. And also, there's so much more acidification of our oceans due to carbon dioxide dissolving in the oceans. This is a really big topic.
But actually on that topic, and I know we're moving a little bit away from hurricanes, but it's still the same general climate-related issue. A lot of people ask the sort of, I guess, species that are disappearing. Hasn't that always occurred throughout history? Is that just a part of the natural evolution, or is there something is there an acceleration of sort of decimation?
Like a mass extinction.
Yeah.
We're going, scientists will say, and I'm not an ecologist, I'm not a biologist, but scientists will say we're in a mass extinction right now. And it's happening much faster than a lot of the extinctions have happened gradually. Now, obviously not as fast as, let's say, an asteroid hitting the Earth, but it's happening very quickly. So yeah, we are in a mass extinction right now. We're losing a lot of our species very quickly.
Right, and so I guess keep returning to the source, what's the ultimate cause of that, and I guess it probably depends if we're talking about the oceans, if we're talking about the rainforest, if we're just talking about different areas.
Well, okay, so let me give you an example. The orangutans are in trouble in Indonesia, and the reason why they're in trouble is because of deforestation. There's a tremendous amount of forests that are being burned there. And a lot of it is being burned for palm oil. Now, if you look at so many of the food products that you eat on a daily basis, you will see that there's palm oil in there. I'm guilty myself. I eat products that have palm oil in them. Problem is those forests are being decimated, and there's no place for these indigenous creatures to live, and they are going to go extinct. The only reason that they haven't yet in many cases is that people are actually there helping them. There are organizations that are actually adopting these orangutans and trying to keep them safe, but their habitat is dwindling to such a small size that. So anyway, that's just one example. I mean, look, we could go on forever, and I'm not. And again, I'm a weather expert. I'm a climate expert. But when you get beyond this, I have good, decent knowledge, but not expert knowledge, and so I really,
Right. So I guess there are the issues of public policy. What can governments do? And I know that's not specifically your expertise. Your expertise is science. You're a scientist.
Right.
If you were to think about the major areas of contribution to climate change, and you mentioned ultimately it's CO2 emissions that have to be brought back, how does that break down? How much is cars? How much is whatever, air conditioning or building houses? Or how does that break down so that we can have a general sense of, okay, what are the different areas that need to be addressed?
Okay, so I don't remember the exact numbers, although I have the pie chart in my head right now. But I don't remember the numbers that go along with the pie chart. But it's actually fairly, a few of them are the big ones. So industry is a big one. The amount of electricity, the amount of power being used by industry, that's a big one. Food production is a huge one. Huge. We can talk about that, and I will talk to you about that because it's important to me too. And transportation. Those are the big ones. And if I forgot one, just forgive me, because off the top of my head, they're all fairly big. They're all in the 20 to 30% range, maybe a little more than 30%, maybe a little less than 20, but in that general range. Let's talk about food. My wife and I do not eat meat. The reason why we did that is because my wife saw a bear rug one time. I was at an event. I was actually doing an event for my TV station, and there was a bear rug in the place that we were at, and my wife saw the bear, and she's a very sensitive individual, and she said, that's it, we're not eating meat anymore. Well, she didn't say we are not eating meat, but as a good husband, I decided to go along with that. So about a little over a year ago, I stopped eating meat. Now, I didn't realize too much at the time that I would have a huge environmental impact. Do you know by not eating meat, you decrease your carbon footprint as it pertains to food by more than 50%? So once you stop eating meat, your carbon footprint as it pertains to food goes down by 50% or more.
And why is that?
Because most food production, most of the carbon dioxide that's being produced is being produced by clearing forests to grow stuff like soybeans. But those soybeans are not being used to feed humans, they're being used to feed cattle. So most of the deforestation in the world, especially in the Amazon rainforest, is happening to clear fields to grow soy, which then goes and feeds cattle. So there's a huge amount of carbon dioxide that's released by not having these forests to take up the carbon dioxide, and by burning them and allowing all that smoke and carbon dioxide to rise into the atmosphere. So it's all interconnected. So if I can say one thing, is that you as a person can make a huge impact. And the reason why I say that is I don't really think that, by not eating meat, I'm making a huge impact, or by me personally driving a Prius that I'm making an impact. What I do think, though, is if I rub off on one person and you rub off on two people, that we can make a huge impact. There's a book called The Butterfly Effect. It's a tiny little book. But basically it just says that you as an individual can have a huge impact on the world. You may not know it. You may be dead, but 50 years from now, they may say, Philippe had this tremendous impact. He doesn't realize what he did, but this is what happened. This chain of events happened because of you. So I think it's more of just setting an example for people. But for me, I know that if I have an electric car, I'm going to save money. If I don't eat meat, I'm probably going to be healthier, probably. Again, it's not, and I would never, and let me tell you something. There's a huge pushback from people who say, who don't want to be told what to do. And I get that. I don't want to be told what to do either. So I would never tell you not to eat meat. I would just say that's a choice that I made. I would never tell you to drive an electric car. That's a choice that I made. These have to be decisions that people make on their own. They can't be forced to make these decisions, or it gets people angry and is a revolt. So. Yeah. I don't know if there's
anything coming up as we're looking for that. Maybe we can also speak about just this discussion that's taking place about does climate change even exist is one that's become extremely politicized.
Yeah.
Right. And on this issue of it seems as though the more one side or another tries to convince the other, the more entrenched,
polarized they get.
Right. Each side gets. Yeah. But when you take a look at the science, it seems that there's a more and more of a sort of a consolidation of opinion on this. Can you speak a little bit to that?
That's great. So 97+% of scientists, climate scientists, I should say, believe that climate change is happening and attributed to human beings and CO2 release and fossil fuel release. 97+%. Now but when you do surveys, only about 15 or 20% of the population knows that. Only 15 or 20% of people know that the consensus within the climate change or climate community is 97, 98% or so. People don't know that, and if they knew that, it may change their minds. But it turns out that the psychology is really difficult, that people who believe a certain way tend to just keep believing that way, and they don't like to be forced into a different direction. This has to be something that happens organically. But there's no debate within climate circles, really. There really isn't. And one thing that the media had done in the 1990s, let's say, was, and it's typical of journalists, and this is a good thing. This is the good thing that journalists do. They always try to show both sides of the story. The problem with that is if right now I gave 50% of my time to people who don't believe climate change is happening, and 50% of my time in a news story to people who do believe climate change is happening, then everybody at home is looking at it and says, well, I guess it's kind of up in the air. There's a 50% chance it's happening and a 50% it's not. And we did that back in the 1990s. We gave 50% of our attention to it's not happening and it's too happening. And it gave the public a skewed view as to what the scientific community believes. But the scientific community, and especially the climate community, overwhelmingly believes that it's happening. And there are very few who push back against that. But there are some, and they're very loud voices, that's for sure.
Yeah. So I guess around that, if the scientific community is saying, this is real, it's happening fast, could happen even faster, we don't know.
It's going to happen even faster.
Then there are some important decisions that people here in South Florida and elsewhere have to make about adaptation. Mm-hmm. Right? So there's some things we can do to mitigate it, which you've talked about. And then in terms of just adaptation, life is going to change around here. What can we be looking forward to or be concerned about? And how do we think about adapting the way that we live here?
And it's a good point. It's because he loves Miami. And how many people here love living in South Florida? You can't see behind the camera, but everyone says they do. The bottom line is we are not going to be pushed out by anyone, right? So the point is that we want to adapt. But I think that technology is going to allow us to do that to some degree. We will come up with solutions. It's difficult on Miami Beach and in Miami because the water comes up from the ground. Believe it or not, and this is going to come as a surprise, but there was a study done that was released a couple of weeks ago saying that the number one most vulnerable city in the United States to a rising sea is New York City. That may not come as a surprise because there's so many people living there. Number two, anyone want to take a guess? Hialeah. And why is that surprising? So people who are watching from South Florida, Hialeah is not on the water. It's inland. But the water comes in from different directions. It's not just coming in from the ocean, so we have to get away from this idea that it's all going to just push over seawalls and push over Miami Beach and over Collins and over, and over ocean and make its way onto the beach and then slowly make it. It's not what's happening. It's coming up from the ground. So these pose huge engineering concerns and obstacles and opportunities. There's an engineer sitting here, right now who probably knows more about this kind of stuff than I do. Do I know how we're going to adapt? Well, I know that a lot of us won't own cars in the future because there will be autonomous vehicles. That makes it a little bit more easy. I have my building on South Beach is elevated. It's on Belle Isle, which is really precarious because it's sitting in the bay on the edge of South Beach. Mm-hmm. But with that said, all the buildings are kind of several feet off the ground, so they don't have to worry about that. But the parking garages do. Well, the solution to that is we may not really need parking garages 15, 20 years from now to a large degree. And obviously these buildings and the city of Miami Beach will figure out ways of they're already elevating streets. I mean, streets are being elevated by 3 feet. So we will adapt. It'll be difficult in some cases, but no one's leaving. I mean, I shouldn't say no one, but I know I love South Florida. I don't plan on leaving. I plan on adapting. And I'm assuming you guys plan on adapting too, right? Yeah, so there you go.
And how do you think local governments are going to have to think about this if there are more storms or more more damage that comes as a result of natural disasters, as we've seen recently in Houston, but other areas? Fortunately, we were spared the worst during Hurricane Irma.
We got lucky. Got very lucky.
But how do local governments think about this in terms of the cost, budgeting, what that's going to entail if we anticipate more damage?
So much of the way Philip Levine got elected was he was talking a lot about water. He was I'm sure there were plenty of other reasons too, but he was talking about water and adaptation to water and raising the streets and putting in pumps. And so it's getting into our politics already. Now, I'm not political. I really can't be political as a journalist, as a meteorologist. I'm a scientist. It's already happening. People are already approving money for projects. I mean, Miami Beach, and I don't know if the number is 400 million or 500 million, but that's how much we're spending. So I think it's already happening. Governments are going to, have to start, putting money into plans to mitigate, because it's going to happen. Sea level is going to continue to rise. CO2 is baked into the atmosphere until we come up with some type of geoengineering solution on a huge scale, which is very difficult. It's there.
Yeah. If there are any questions, please feel free to ask.
Yeah,
yes?
Sure. Go ahead. This is Philip again. Philip's far away from the camera.
When I'm thinking a lot of these, I see a lot of analogous to the tobacco industry and kind of the information that they did. Philip Morris USA misfed information, and I think it's very similar to kind of what we're seeing with climate change.
Right.
Where we know the effects. They've been saying, the scientific community from the onset was saying that this is damaging to your health, this is bad, but it took almost a generation, or at least a decade or two, for people to actually see the effects. So that's the way I see us kind of being in the middle of the second decade, where we're starting to say, okay, no, this is real.
It's tobacco again. It's smoking cigarettes again. Well, why don't you repeat what?
Yeah, so basically it's drawing the analogy to what transpired with the tobacco industry that essentially mischaracterized what the science was saying about the effect of tobacco on the human body.
Yeah.
And now, I guess some people claim that there's a similar type of initiative that's being led to dispel the realities of climate science so as to make sure that when certain public policies are not, coming out that are contrary to their interests.
Yeah, I see it as probably being the case. I mean, it has obviously a lot to do with just money and business. One thing I think we will find, though, is that if we do things the right way, the sustainable way, there's a lot of money to be made. I mean, one thing that I will bring up is wind power and wind turbines in the middle of America, in Texas even. There's a story of a town in Texas that was very down on its luck, especially after the economy crashed back. Was it 2008 that the economy crashed? It feels like it was yesterday for whatever reason. But, and this small town in Texas, was losing a lot of their youth. A lot of their young people were leaving because there was no opportunity there. Restaurants were closing. enter the wind industry. They are allowing farmers to put these turbines on their farms. The farmers rent this space to them. They're making a lot of money off of this. They're creating jobs. The amount of jobs that are being created in the solar and wind industry is huge, especially the solar industry. And so by embracing sustainable energy and by working with Mother Nature and not against Mother Nature, we are coming up with solutions that not only are equal to but superior in many ways, because they're producing jobs. It costs less economically for us to tap into energy. I have wind energy, which may come as a surprise here in Florida. I subscribe to a company called Arcadia. Now, I don't know about, I'm sure there are a lot of other companies like it, but it allows me as a Floridian to actually sign up for wind power. So I have wind power at my house. Wind power is not accessible in Florida, but it's a weird thing. Basically what I do is I buy wind credits, and the wind energy flows into the grid out west, and by pushing more wind and solar energy into the grid, there's less fossil fuel energy that can be used. So in a very inadvertent way, I'm using wind energy because I'm purchasing wind credits, and it doesn't cost me really any more. Actually, it doesn't cost me more to use 50% of my energy through wind. It costs me $10 more a month if I want to use full wind. Anyway, but it's something you might want to look into if you're interested in this kind of stuff.
Yeah, and I guess we have a little bit more time, but I guess this is more of a personal question. I'll take the entree. As a scientist that seems to, I imagine, deluged, so to speak, by negative information about what's going on in the climate, how do you maintain the sort of optimism that I think is necessary to continue to embrace this and be thinking about how to report this straight and how to also maintain hope for what awaits us?
The funny answer is drugs. No, I'm kidding. I'm kidding. I'm totally kidding with you. It is frustrating at times. But I do have a tremendous amount of optimism, and it's not because, listen, I think people are good-natured. Not all, but some. But I don't think that's how it's going to happen. It's going to happen because of the economics. And that's why I'm optimistic. I'm optimistic because it's going to be cheaper to drive an electric car. Yeah. More jobs are going to be created through sustainable energy. All these things are happening because they make technical and economic sense. And as long as the economy, as long as capitalism is driving it, it will be successful. Mm-hmm. So ultimately, we're moving in the right direction. I think it's going to happen. I really do think that there's a revolution happening in this industry right now. And we're seeing it in front of our eyes. In 20 years, we're going to look back and we're going to say, it happened pretty quick. I really do, and I think it's mostly driven by money. That's my honest opinion. I think it's just going to be cheaper. It's hard to swim upstream. So if at some point it's going to become impossible for people to swim upstream and go against what is the tide, which is turning, which is that it's just a better alternative.
And it seems like that's happening faster in some areas than others. It seems like counterintuitively, in China, there seems to be it seems that they're embracing alternative energy much more quickly than perhaps even in the United States. Is that right?
Yes, and there's a reason for that. First of all, obviously, China is very polluted, or it had been getting so polluted that they had to stop these coal plants. But it's not just about that. It's developing nations versus a place that's completely developed like America. People always say, "What's wrong with American airports?" Well, they were built, 30 years ago, and no one's going to invest the money to rebuild them now, right? Well, and I'm not saying no one, but we'll get there, but it takes some time. So we have all this existing infrastructure in the United States. If we wanted to start building solar and wind, we have to build from the ground up. We have to get seed money. We have to, or a company like FPL has to invest tons of money to build the infrastructure from the ground up. In these developing countries, especially in the Middle East and in Africa and to some degree in China, it's cheaper to just build solar from the ground up than try to build fossil fuels from the ground up. Here, it's a little bit more difficult because we already have the existing infrastructure, and you have to convince people to spend millions and millions of dollars to build new solar plants when we already have ways of getting power. So from the ground up, in developing nations, it's cheaper now to go with solar. Not everywhere, but in many places. In Europe, it's wind. In places like Africa and the Middle East, it's solar. And that's why I'm optimistic. The United States has a little bit more of a problem in that our infrastructure is pretty good, and it's been around for 100 years.
Yeah. How are we doing on time?
We've got maybe another 5 minutes for questions.
All right, another 5 minutes. So anybody have any other questions here? And I just have to say, for anybody that's watching right now, I am not an expert on energy. I am not an expert on government. I am an expert on weather and the climate to some degree. I'm an atmospheric scientist. That's what my background is in. So if I said anything that wasn't exactly entirely true, forgive me, because because it's not my expertise. So when I get into these other areas, I know enough to get myself in trouble. Let's put it that way, right? So, yeah.
From my point of view, Jeff, you have an excellent speech. I'm working in wind energy for years.
You've been in wind energy. What's your name, by the way?
Yeah, and basically we are trying to talk.
Edward works in the wind industry.
Yeah,
Okay.
Edward from Vortex. To talk to climate change, we talk to the economics. This is the key. Because
Yes.
it's true. In order to change the mind of the people, you say climate is there, climate change is there, is a fact. But you have to talk about economics, because it's the only way to change the point of view of
And that's why I'm optimistic. And so it's Edward, right?
Yeah.
Edward was basically saying he works in the wind sector, and to change people's point of view, it's really simple. He changes, it's just the economics have to change. And as they change, it's easy to change people's minds about the way that they should go, right? Yeah.
I don't know if you touched this on a little bit earlier or not, but the Paris Accord.
Yeah.
So I completely agree with you that we are going because of the technology and because of cost.
Yeah.
But my concern is, from a political standpoint, we've been kind of shying away. Right? The head of the EPA has no idea what science is, apparently, and that's been proven already because he said it himself. And a lot of the government right now is not very pro-science or pro the environment, per se.
Yeah.
So my concern is, for example, when China is going completely heads first, which arguably right now is probably the leader now in alternative energy and dealing with climate. So what do you see, or what do you think is the impact? Do you think we're really going to leave the Paris Accord completely, or do you think we're it will completely affect us all, depending on how that turns out?
So why don't I let you rephrase that?
Sure.
Yeah.
So
that was Philip.
Yeah. Okay. Philip was again sort of commenting on the fact that the technology and economics are really what's going to drive the change towards different types of alternative energy and whatever else is necessary. Right. And the recent removal or retraction from President Trump on the Paris Accord, the question is that actually going to happen? Is the United States going to be pulled out? What can we expect?
Donald Trump's not on my speed dial, so I don't know. I don't know the answer to that. I really don't know what we're going to do. We are sending representatives to the climate talk, which is happening this week. So the IPCC has a climate talk. I think it's next week in Bonn, Germany. So we are sending representatives there. Whether or not we completely pull out of the Paris Accord, I don't know. I can't even speak to that. Really, I can't even talk politics with you, to be honest with you. But I do think that governments can help set the stage and kind of set the policy and help to push us in the right direction. And obviously, but I think most would agree, it's not just the United States, by the way. It's most countries are not moving fast enough. They are not moving fast enough. So what's interesting, over the past 3 years or so, the amount of CO2 that's been released by the United States, Europe, China, and Russia is stable now. We're not going up. We're not actually releasing more CO2 into the atmosphere anymore. So we have effectively stabilized the amount of CO2 we're releasing into the atmosphere. The problem is 4 years ago, the amount we were releasing was too much, and so it's still too much. So we need to see that curve bend down quickly. And in order to do that, it's probably going to take some government initiative and essentially supplement the industry. Right now, there are supplements for fossil fuels. The government does subsidize fossil fuels. So there's going to have to be some subsidies for alternative energy. It doesn't have to be. I call it alternative, but really it's just sustainable now. It's not alternative anymore. But that's not something that I can talk to. It would help, sure. If money goes into those subsidies, then it would help kind of make things a little easier. But I think it's going to move in that direction just more slowly, I guess, is the answer to your question. I don't know what our government's going to do.
Great. I think we have time for one.
Question from our viewer, Mauricio Rubio, and kind of bringing it back to the beginning. Do we have any idea what the hurricane forecast for 2018 is looking like?
Okay, so he wants to know the hurricane forecast for 2018. And his name is Mauricio? Mauricio, I would be a very rich man if I knew what was going to happen in 2018. Sometimes we see these happen in 2-year cycles, 2004, and then again in 2005. If you were down here in Florida, you know.
We went how many years without getting hit, getting spared?
Yeah, we did.
Several years.
Yeah, we went 11 years or so without a landfalling hurricane in Florida, something like that. It was a record amount of time. So you see there's cycles involved here. There were plenty of hurricanes in between 2005 and 2015 or whatever, but a lot of them just didn't hit land. So sometimes cycles are not only up and down in terms of the number of storms you get, but they're also in terms of the placement of those storms, the track of those storms. Sometimes they have more of an affinity to hit Florida, sometimes more Texas, sometimes the middle of the Atlantic Ocean. It's interesting. We're looking at maybe a La Nina. And if we get into a La Nina, then we're looking at probably an intense hurricane season again in Florida maybe next year. Again, but the devil is in the details. I mean, if the hurricanes don't hit land, well, that's fine, right? So it would be devastating for more hurricanes to hit the Caribbean. I mean, it would be Barbuda is uninhabited now. The first time it's been uninhabited in like 300 years. I mean, population is small on that island. Dominica, 75,000 people living there. Almost the whole island's been destroyed. We all know what's happening in Puerto Rico. It is still an ongoing human tragedy there. Unfortunately, the Mother Nature chose the Caribbean this year to be the place, and southern Texas, and obviously Texas coast as well. We got lucky again. Irma kind of missed us. I mean, it hit Florida, but as a much weaker storm. And when I say missed us, I mean southeast Florida. Miami got hit hard, but can you imagine a Cat 4 or Cat 5 coming right up I-95 through Miami, Fort Lauderdale, and West Palm? It's unimaginable in terms of what would happen when it hit, and then unimaginable as to how we would have the humanitarian response to it. It's hard to imagine, and I really hope it never happens. But anyway, in answer to the question, 2018, it's probably going to be an active year based upon just larger scale patterns, but we don't know. There's no way of really knowing that. Yeah.
I think that's all.
Okay.
Great.
All right,
This is
sir.
great. Thank you so much
Thank you
for
for inviting
joining
me
us.
down. Yeah, of course.
All right.
All right, everybody. Bye-bye.